Hello viewers, in today's session we are going to discuss an important concept in vector analysis, and here we are going to discuss the concept of coplanar vectors with the help of this problem, right? So here we have to show that these three vectors, that is 5a plus 6b plus 7c, 7a minus 8b plus 9c, and 3a plus 20b plus 5c. These three vectors are coplanar, where a, b and c vectors are non-zero and non-coplanar vectors, right? So here we'll see the coplanarity of three vectors with the help of the concept of linear combination of vectors. Suppose we have three vectors, say vector u and a vector v and vector w. Now these three vectors are said to be coplanar vectors if these three vectors lie on the same plane, right? But here we'll prove the coplanarity of these three vectors with the help of linear combination of vectors. Suppose u, v and w represents these three vectors, right? And these three vectors are said to be coplanar vectors if any one of them can be expressed as a linear combination of other two vectors. So now consider two scalars L and M. So L and M are two scalar quantities. Now if we are able to express the vector U as a linear combination of vector V and vector W, then these three vectors are said to be coplanar vectors, right? So we can now write vector U as LV, and here we have mw, right? And we can also write the vector v as a linear combination of vector u and vector w. So here we have lu vector plus m w vector, and similarly a vector w can be expressed as a linear combination of vector u and vector v, right? So these three expression represents the linear combination of one of these vectors in terms of other two vectors. And always remember this representation is unique, right? So when we have any three vectors, vector u, vector v and vector w, then these three vectors are said to be coplanar vectors if any one of the vector can be represented as a linear combination of other two vectors. So now consider these three vectors as vector u, vector v and vector w, right? And now we'll prove that these three vectors, that is vector u, vector v and vector w, are coplanar vectors with the help of this concept, that is linear combination of vectors, right? So if we are able to express any of these three vectors as a linear combination of the other two vectors, then these three vectors are said to be coplanar vectors. And remember, three vectors are said to be coplanar vectors if they lie on the same plane. So now let us make use of this vector equation, right? So here we have a vector u as 5a plus 6b plus 7c, and here L and M are any two scalars. So here we have L, and vector v is 7a minus 8b plus 9c, and here we have m, and vector w is 3a plus 20b plus 5c, right? So using this equation, we have now this expression. We can also use these two equations also, and we'll get the same result, right? So here we'll prefer this one. So now let us simplify here. We have 7L, and from here we have 3M, right? So the coefficient of vector A is given by 7L plus 3M, and then the coefficient of vector B is given by minus 8L, and here we have 20M, and the coefficient of vector C is given by 9L. Here we have 9L, and here we have 5M, and here we have the vector C, and here we have 5A plus 6B, and here we have 7C. So what we have done here, here we are trying to express this vector u as a linear combination of vector v and vector w. So now here the in the left hand side, the coefficient of vector a is 5. Here the coefficient of vector b is 6, and here the coefficient of vector c is 7, right? And here the coefficient of vector a is 7L plus 3M. Here the coefficient of vector b is minus 8L plus 20M, and here the coefficient of vector c is 9L plus 5M. So our next aim is to compare the coefficients of vector a, vector b, and vector c on both sides, and will frame three linear equations, right? So we have here 7L plus 3M is equal to 5, and then we have minus 8L plus 20M is equal to 6, and here we have 9L plus 5M is equal to 7, right? So writing this vector u as a linear combination of vectors v and w, we have now these three equations. Now let us take this as equation 1, this is as equation 2, and this is as equation 3. Now we can select any of these two equations, and we will solve the two equations to get the value of L and the value of M, and then we'll see whether the values of L and M obtained by solving any of the two equations is satisfied by equation that is the equation 3 or not. So now if the values of L and M obtained from solving equation 1 and equation 2 is satisfied by equation 3, then we can claim that the vector u can be expressed as a linear combination of the vectors v and w, and the three vectors u, v, and w are coplanar vectors. So now let us solve equation 1 and equation 2 by the usual method of elimination. So here we'll equate the coefficients of L in both the equations. So here we can multiply this equation by 8, and this equation by 7, right? So here we have now 8 times 7 is 56 L, and here we have 24M, and here we have 40, and here we have 7 times minus 8 is minus 56 L, and then we have 140M, and here we have 42. So now we can add these two equations. So these two terms get cancelled. Here we have 4, this is 6, this is 1, and here we have 2, and here 4 plus 4 is 8, right? So the value of m is 82 divided by 164, that is equal to half, right? So now the value of m is half, and the value of L can be obtained by substituting m is equal to half in either equation 1 or equation 2. So here we'll substitute m is equal to half in equation 1. So we have 7L plus 3 over 2 is equal to 5. So we have 7L is equal to 5 minus 3 over 2, that is 10 minus 3 over 2, that is 7 over 2. So we have here L is equal to 7 divided by 7 times 2. So this is half, right? So here the value of m is half, and the value of L is also equal to half. So now let us see whether the values of m and L satisfy equation 3. And if these two values satisfy equation 3, then we can say that the vector u can be expressed as a linear combination of these two vectors, vector v and vector w, and the three vectors are coplanar vectors, right? So let us substitute the value of m and L in equation 3. So here we have 9 times half, that is the left hand side here, plus 5 times half, right? So L is half, and m is also half. So here we have 9 over 2 plus 5 over 2, that is equal to 9 plus 5 over 2, that is 14 over 2, that is 7. And here in the right hand side we have 7. So the values of L and M satisfies equation 3. So we can now claim that the three vectors, vector u, v and w, which are given by these three vectors, are coplanar vectors. And always remember, when we express the vector, one of the vector, as a linear combination of other two vectors, then this combination or this representation is unique. So therefore the three vectors are said to be coplanar vectors. So now here it is interesting to note that if we use these two equations, then we'll get the same result, that is the three vectors are coplanar vectors. So let us now use this equation. So here we have a vector v expressed as a linear combination of vector u and vector w. So here v is 7a minus 8b, and here we have 9c, and then we have L, and vector u is 5a plus 6b plus 7c, and here we have m times vector w, that is 3a plus 20b plus 5c. So now let us again collect the coefficients of vector a, vector b and vector c in the right hand side. So now here we have the coefficients of vector A, vector B and vector C. And here if we compare the coefficients of vector A and vector B and vector C on both sides, then here we can now frame the linear equations as 5L plus 3M is equal to 7. Then we have 6L plus 20M is equal to minus 8. And then we have 7L plus 5M is equal to 9, right? So now let us solve equation 1 and 2 to get the values of L and M. So now let us multiply this equation by 6 and this equation by 5. So we have now here 30L plus 18M is equal to 42, and here we have 30L plus 100M, and here we have minus 40, right? So now here equating the coefficients of L, we have now these two equations. So now we can subtract these two equations. So here these two terms get cancelled, and here we have 18 minus 100M, that is equal to minus 82 M, and here we have 42 plus 40, that is equal to 82. So the value of M is 82 divided by minus 82, that is equal to minus 1. Now substituting M is equal to minus 1 in this equation, we have 5L minus 3 is equal to 7. So 5L is equal to 7 plus 3, that is 10. So L is 10 over 5, that is equal to 2. So now the value of M is minus 1, L is 2. Now substituting L and M in equation 3. So here this side is now, that is the left hand side, is 7 times 2, and here we have 5 times minus 1. So this is 14, and here we have minus 5, that is equal to 9, right? So we can see that the values of L and M obtained by solving equation 1 and 2 satisfies equation 3. So we can claim that the vector V can be expressed as a linear combination of the vectors u and vector w, where L and M are some scalars, right? And hence we can again claim that the vectors u, v, and w are coplanar vectors, because the vector v can be expressed as a linear combination of these two vectors, vector u and vector w. And remember, this representation is unique. Now, similarly, if we use this expression, then we have this equation, right? So, if we express the vector w as a linear combination of vector u and vector v, then we have this equation. And again, following the same steps, here we can collect the coefficients of vector a, vector b, and vector c on the right hand side. So here we have 5L plus 7M, here we have 6L minus 8M, and here we have 7L plus 9M. And now comparing the coefficients of vector A, vector B, and vector C on both sides, we have now three linear equations. So following the same steps, we can now solve equation 1 and equation 2 by eliminating the coefficients, or eliminating this variable m. So multiplying this equation by 8 and this equation by 7, we have now here 40L plus 56M is equal to 24. And here we have 42L minus 56M, and here we have 140, right? So now if we add these two equations, then these two terms get cancelled, and here we have 2, here we have 8, and here we have 4, here we have 6, and here we have 1. So the value of L is 164 over 82, that is equal to 2, right? So here we can now take L is equal to 2 in equation 1. So we have 5 times 2 plus 7M is equal to 3. 7M is equal to 3 minus 10, that is minus 7. So the value of M is minus 7 over 7, that is equal to minus 1. So now taking L is equal to 2 and M is equal to minus 1, let us see whether equation 3 is satisfied or not. So here the left hand side is 7L plus 9M. So we have 7 times L is 2 and M is minus 1. So we have plus 9 times minus 1. So we have 14 minus 9, that is equal to 5, and this is equal to our right hand side. So the values of L and M as obtained from equation 2, 1 and 2 is satisfied by equation 3. So we can now again claim that the vector W can be expressed as a linear combination of vector u and vector v, where L and M are some scalars. And remember, this representation is unique, right? So viewers, in this session we have discussed that if we are given three vectors, then the three vectors are said to be coplanar vectors if the vectors lie on the same plane. And here we have used the concept of a linear combination of vectors to prove the coplanarity of three vectors. That is, if we have three vectors, vector u, v and w, and if any one of the vector can be expressed as a linear combination of the other two vectors, then the three vectors are said to be coplanar vectors, right?